wake up and I'm like, no, this teacher. I was like, sorry.
Sorry that I was in surgery.
She used to it. Second one of the year.
And it's only changing for me.
No, it was last year. I haven't had any this year. No, we met our deductible, so we didn't have to pay anything.
All right, guys, so
That's why I did it last year.
just because there's often a few people that don't know cards too well, which is unfortunate, and I don't mean how to play Texas Hold'em or something. I just mean cards. How many cards are there? How many? What are the suits? How many suits are there?
4.
Exactly. So not everybody knows cards as well as other people. So I might use cards. They're beautiful for probability questions. They just are. Let's probably get a king. Let's probably get a red jack. I mean, they're just beautiful for probability. But too bad for me. So let's say I have a little hat. He's got 4 red chips, 6 blue chips, 12 green chips. Like poker chips. You with me? Not tortilla chips. Or tortilla chips if you want to look at it that way. But then they might get eaten. It's like playing poker with Oreos, and all of a sudden I don't have any money because I ate it. You ever done that? So let's start off with a nice, easy question. And then we're going to build up to some harder ones. And some of you guys might remember that this is probably going to lead into the definition of and somehow. That's what I said earlier I was going to do. So let's start off with a nice, easy, basic question. Let's probably pick a red chip if I pick one randomly.
1 out of 22.
4 out of 18. 22.
Yeah, 4 out of
22.
22. I like it. Now I'm not going to pick on you, but you reminded me of something. What do you think the person that's looking at it this way, how are they looking at it wrong? If they say the answer to the probability of red is 1 out of 4.
They're not adding them.
How are they looking at it? They're looking at it like there's 4 reds and I want 1 of them.
There's only red in the hat.
Yeah, see, that would imply that there's only red chips in the hat and there's 1 of those red chips you want. But no, I got 4 chances to get a red chip out of 22 things that could happen. That's the right way to look at probability. It's got to take into account all the things that could happen. Yeah, like it. And 4 out of 22 is
18.18.
18.18? Yeah. Neato. I like it. Okay. And then, probably blue, blah, blah, blah. What's probably blue?
6 over 22.
Yeah, 6 out of 22, which would be?
27.
Yeah, 27.37.
27.
27. 27? Oh, yeah, 27. Gotcha. And then probability of green, 12 out of 22.
54.55.
55. Okay. So that's nice basic stuff. I'm only picking 1 chip. So now I'm going to pick 2 chips. And I have to be specific about how I pick them. Because how could I pick 2 chips out of the hat? I could go in and just pick 2 chips at once, right? But see, that's interesting because that actually changes the probabilities of things. Because if I pick a chip, and then I always joke that I feed it to my little brother, what happens to the probabilities of everything left in the hat? They'll change. So if I picked a red chip out and I threw it away, and then I go to pick another chip, what's going to change fundamentally? The bottom is going to be 21 now. All the probabilities change.
But wouldn't also the red also change?
Of course.
Yeah.
But the bigger thing is all the probabilities change. Red changes even more for 2 reasons. So I have to be very specific. I can pick 2 chips without, let's say with replacement first. Can you make letters, Jeff? There you go. If I pick 2 chips with replacement, meaning I pick a chip, I put that one back in, and then I pick a chip. Could I pick the same chip twice?
Yeah.
Yes. But the nice thing, all the probabilities stay the same. Because I'm putting that first chip back in.
Okay.
The bottom is still going to be 22, right? So if I pick 2 chips, what's the probability that I get a red and then a blue? Not red versus blue. Red and then a blue. No red versus blue chance? Really? Is that no? Oh, there you go. Thank you. Humor you, teacher, man. So, what's interesting here is there are 2 probabilities that I have to consider. What's probably get a red chip?
18%.
Well, 4 out of 22. Never use this in the middle of work because is this the exact answer? No, that's an approximation, right? It's going to throw your last answer off. You never round in the middle unless your teacher says you can. So probably red and the blue. I look at this as there's 2 things I have to fill in. And what does and basically mean? Multiply. So it's probably the first one's red, 4 out of 22, times, I throw that one back in. Now what's probably the next one's blue?
6 out of 22.
6 out of 22. They're really far away.
20.
Not 21. Why not 21? What's?
That's 6 out of 121.
Oh, I see. Okay. Yes, then. Because that would be 2 11s times 3 11s, 6 out of 121, which is roughly
4.96.
4.96%.
Yeah.
What's happening? What's the matter? This is
24
You know,
out of 44. Oh, he simplified it. Okay.
here, guys. So everybody that is looking at me like I've been saying, do you have any trouble with what's written there right now? Not anything else that we said. What's written there right now? Where'd this come from? Where'd this come from? Red. Put it back in. And then where'd this come from? Probably blue. And means multiply. We went over that a few times. Okay, I like it. Now, everything else that was said was just throwing this shit in the calculator, right? So if you need a calculator, come get one.
So do 4.9.
Hopefully that will decrease the number of weird looks I get. Yes? No, because what did I do with that first chip? I put it back in with replacement. I replaced that first chip. I put it back in.
So, yeah, 24 out of 484 or reduced to 11.
True. And what is it? Percentage again, sorry?
4.959.
959?
Yeah.
96.
Is 9599 or something interesting?
586 is basically what it is. So we don't have to go to 4?
586. Okay. I'm crowdsourcing. You guys got to work with me. How does everybody feel about that right there? So if I pick 3 chips, red and then blue and then green, it would just be 4 out of 22 times 6 out of 22 times 12 out of 22. I mean, I could just keep adding more shit on there. And it just keeps multiplying because it's red and then blue and then green or whatever. And means multiply. So what happens if I do this same problem but I pick 2 without replacement? Probability of red and then blue. So now the first one, the first chip I picked, it's still got all the chips in there. Nothing's happened yet, so I pick out a red one. What's the probability that happens? 4 out of 22 times. That would happen. And then I throw it away. Yeah. There's still 6 blue chips, but out of 21 chips. Now real quick, just to go back to the formula from earlier. This is red and then blue. 4 out of 22 is the probability of red, right? What is 6 out of 21? It's not the probability of blue. Probability of blue is 6 out of 22. 6 out of 21, why? It's probably a blue given that I picked a red one. Isn't that? Why did that probability change? Because before this happened, something else happened that affected it. So what is this then? It's probably a blue given red. Isn't that the freaking formula for and? Red and then blue is probably red times probably blue given red. Look back at your formula for and. That's the formula. Why didn't this one change?
Did you replace it?
Because the first thing didn't affect it. I put that first thing back in. It didn't affect it. Talk more about what that is a little bit later. Okay, maybe. Again, what's the formula for and? It's probably of A times probably B? No. Times probably of B given A. That's why this is probability of red times probability of blue given that I picked a red. That's why the second one changes in this case, because I did throw that first one away. This is still blue given red, but in this case, why didn't it change? Because I dropped the first one back in. We didn't go back to this formula, did we? We just did what made sense, didn't we? We did what made sense, and hey, it's what the formula says to do. Wow. All right, I can tell you guys love this shit. All right, let's try another one. So still picking 2. Let's pick 2 with replacement. Let's probably I get a green and then a green. Try that one out. A green and then another green. With replacement. Get some sustenance. I can keep going.
29.75%.
29.75.
Is that all you guys got?
Yeah, I got
What's up? Yeah. You good? What'd you do? But why 6? Green. How many greens are there? Yeah. Okay. That's all right. That's a good mistake to make because it's really easy to fix and really easy to make sense of. Now, do that same thing again, but now pick 2 without replacement. Probably green and then green.
31 point.
I don't know.
How many decimals did you say you usually use these with?
Do not round this to 4 places and this to 4 places and then multiply. If you round in the middle of your work, your answer will be off, guaranteed. So what you do is, how do you set, what's the work you show me is setting up these 2. This would be 12 over 22 times
11 out of 21.
11 out of 21. Why 11? Because I lost the green one. I get a green first. It happens 12 out of 22 times. Throw that one away. So now probably a green one again is going to be 11 greens out of 21 chips.
8.5.
And you see how this isn't really that hard. It's just counting. I lost a chip. I lost a green. I'm just counting. But it is doing what the formula says to do, just naturally. That's actually the way everything works. Yes, there are formulas for how a basketball goes through the air. Do you have to know the formula to do the throw of the basketball? No. But it's going to follow the freaking formula. It's just naturally. Sorry, what did you get again?
28.57.
28.57? 20 who?
why did you get 11 at, wouldn't it stay at 12?
Well, no, because what did I pick first? I picked the green one without replacement, so I throw it away.
But how did you know you picked
Ah, I love it. This is probabilities. The only things I'm going to count as a part of this answer are the ones where a green one did happen. How often does that happen? 12 out of 22 times.
Yeah.
Out of those times, how often will we get another green one? Well, I threw the first green one away.
But you don't know that.
This is all about what could happen. So what are the only things I'm going to include here where these things happen? That's how probabilities work. So 12 out of 22 times, you will get a green one. So what situation am I in so far where I got a green one first? I throw it away. Given that that happened, what's probably that the next one's green also? I got 11 greens now because I just threw a green one away. So I love that question. I haven't had the question in a while, but I wonder how many people think that sometimes. This is all possibilities. I'm not saying yes, a green one happened. I'm saying right here, 12 out of 22 times a green one will happen first. Out of those times, how will I get a green one second? Well, I just lost a green one.
But wouldn't it stay at 12 though, since you don't know that?
No. The only way to get to this step is to have picked a green one first. Otherwise, I'm not counting that. If you pick a red one first, that's not going to be a part of this answer. So the only way to get to the next step is to have already picked a green one and thrown it away. So now there's 11 green out of 21 chips. I like it. Nowhere am I saying that a green one happened first. This is all probabilities that a green one happened first. But if it did, then that's the probability that the next one would be green. Yes? Why didn't the tops change on the previous one? Because it was a red that I picked. So how many blues are left? All of them. Right? If I pick a red one, there's 3 reds, but the next question was a blue. There's still 6 blues. It was a red one I picked. Why did this one change? Green and then green. So I lost what I was looking for next. I love it. Some of you guys are like, my brain hurts. Yes, it does involve thinking. And it's not something that's impossible to understand. You just have to push yourself a little bit and actually think about the situation. It'll make sense. Okay. So that's that idea. Let me finally shut up, and I'm saying what's in some of your heads. And there's a side of this that says, this side in class. So do that side. The other one is what I'm going to have an answer key for tomorrow. It's kind of like my practice thing for the probability mini test.
For that question, if we change
Chapter 38 probability.
Which is chapter 3. Wait.
and then say what
At the bottom of the change.
No, just 3.
The only reason top changed on the second one is because I lost the green.
Yeah.